Right, example 7. So this one, a block of mass 200 kilogram is pulled along an inclined plane of 30° by a force. So this one actually I've updated in your lecture notes. I just haven't updated it here. So this force should be F should be 2 kilonewton. Okay, so the coefficient of kinetic friction of the plane is 0.4. Determine the normal force, net force, acceleration of the block, and the time taken for the block to travel 30 meters from rest. Okay, so what information we have? 200 kilogram. Then we have the kinetic friction, coefficient of kinetic friction, as well as the force there lah. Okay, so that is all the information that we have. Now we have to draw the free body diagram. So we have this, and then so we have weight, and then we have, oh, before that we have to consider the inclined plane. So we have something like this as the inclined plane. Okay, and then now we can start draw the forces. We have the kinetic friction, we have the force, and then we have the normal force. Okay, the only force that we are not gonna draw is the tension, because there's no tension in this situation. So we have mg, fk, n, and f. Okay, the angle, this one is 20°, and then the axis for y component is something like this. Okay, so this 30° angle here, the 30° angle ni will always equal to the y component lah. So kalau mg ni di sini, yang 30° ni di sini. Okay, so this one here is 30°. Okay, so that is our free body diagram, completed free body diagram. Now we can start to answer the question. So now we are looking for the normal force. So for the normal force, we can just use the y component. So total force at y component is equal to 0. So why is it equal to 0? It's because the block does not move up and down like this. It only slides to the left or to the right up here. Okay, so in that case, I have to also write the acceleration is going to here. This is the acceleration. Okay, so let's look at the y component sahaja. Now n is positive plus f sine 20°, and then we have the mg going down cos 30°. So this is our x, this is our y axis. Okay, so now we let this equal to 0. So here n is equal to mg cos 30° minus f sine 20°. Okay, so we have all the values. M ada, f pun ada. So just substitute into the formula. You'll then get the normal force to be 1015 Newton. Okay, now the net force pula. The net force is only for the position yang ada acceleration. So in this case, for the x component saja. So F net is equal to total force at x. Okay, x component saja. Okay, so F net is equal to, yang follow acceleration is positive, yang going against the acceleration is negative. So F cos 20° is positive, minus fk sebab dia against the acceleration, and then minus mg juga sebab dia pun against the acceleration, sine 30°. So that is the x component. So f cos 20° minus mu kn minus mg sine 30°. So we have all the values here. Just substitute, and then you'll get the net force to be equal to 492 Newton. Okay? Boleh kan? Senang je ni. And then question C pula apa dia minta? Dia minta acceleration of the block. So acceleration of the block, we know that the F net is equal to ma. Okay, this is the Newton's second law of motion. So we have the net force, which is 492, equal to the mass, which is 200 kilogram a. Then you'll get the acceleration to be equal to 2.46 meter per second square. Okay, and then final question, we have to find the time taken for the block to travel 30 meter from rest. Okay, so this one is just a combination of chapter 2 and chapter 4 lah. So the formula that we will be using is based on the information dulu lah. So we have S equal to 30 meter. The distance yang dia perlu travel is 30 meter. And then it states that the velocity, initial velocity, is equal to 0. Okay, so now we can use the formula ut plus half at square. Okay, so why do we use this formula? It's because we need the time. Okay, if we use vu plus at, we do not have the final velocity. Okay, that's why we use this. Right, then substitute the values, all the values, you'll then get the time to be equal to 4.94 seconds. Okay, so that is our solution for example number 7.